Hi guys, welcome back here at the Easy Engineering Tutorials. So this time is we'll just continue on our discussion on the design of drainage channel. So sa video na to is we'll be discussing the rapid buried flow analysis. Okay, so considering meron tayong section 1, 2, and 3, we have this channel 3 and channel 2. So yung side slope, yung bed slope ng channel 2 is 0.005 while yung sa channel 3 is 0.003. So we have this steep slope and we have this mild slope. Okay, so again, yung YC, yung critical depth is constant sa lahat ng channel. We have that critical depth. So since andito tayo sa sa steep slope, so the safe way to assume is supercritical yung nangyayari, no? So yung YN is less than ng YC. Dito naman sa mild slope, the best assumption would be subcritical yung depth, no? So meaning yung YN is greater than the YC. So we have two possible scenario na mangyayari sa hydraulic jump. It could be 1 and 2. So we have this rapid buried flow RBF and then followed by GBF, or we can have the GBF followed by RBF for the non-uniform flow. Okay, so we perform the logic test. So we just assume that itong scenario 2 is true, and then we calculate for the sequent depth sa upstream, no? So ayan, so let's say dito sa scenario to, ayan, so we have this mild slope and we have this steep slope, no? We have this different zoning, so therefore yung GBF natin dito is considered M3, no? Sa zone 3. Okay, we have this M3. So channel 3. Okay. So yung side slope natin dito is 0.003, no? So ito yung i-consider natin. Kasi yung goal natin dito is makompute muna natin yung YN, no? So we have this formula for the flow rate. We substitute all the values. So we compute for the depth. We have 4.74 feet, so meaning yung YN is 4.74. So we have this YN dito sa steep slope which is 4.74 feet. Diba? So ngayon, kukumputin na natin yung YUS, no? Para alam natin kung ito ba talaga is above the 4.74, meaning pataas siya, no? Parang gagawa na siya ng hydraulic jump, no? Pero kung less than siya, meaning hindi siya gagawa ng hydraulic jump, no? Kasi mas maliit eh. So yun lang yun, no? So meaning kung mas maliit siya, yung possible scenario 1 yung mangyayari, no? Okay, so we compute for the sequent depth for the upstream of the hydraulic jump. So the formula is this one. So ayan, we just need to substitute. We have 9.24 divided by 2. Okay. And then okay. So yung velocity we have itong 9.24 continuation to sa GBF, no? Yung previous video. So like dito yan, no? Itong YDS hydraulic jump yung kino-consider natin. So ito yung kino-compute natin. So yung YDS itong sa mild, which is na-compute natin sa part 6 ng video. Okay, we just need to substitute that one. So therefore yung YUS natin is 2.389 feet. So nakikita natin na yung 4.74 is going down 2.389 feet, meaning yung assumption 2 is incorrect. So mali yan. This simply means that the hydraulic jump occurs in the steep section or in channel 3. Take assumption 1. So alam na natin na malabang mangyari yung assumption 2. So ito yung mangyayari. Okay? So ganyan yung mangyayari sa tubig natin. So again, mild slope, steep slope. We do the zoning, we have S1. Ayan, no? So bali yung YUS dito sa hydraulic jump natin is again, equal to yn nung steep, which is 4.74 feet. Yung issue na lang is itong sequent depth natin na YDS. Anyway, meron tayong formula for that and we can compute for that. No? So, yan na. So for YDS, we have this upstream. Okay, 4.74. So, yung velocity is 13.56. Electric substitution lang yan lahat. So, you have this YDS, which is 5.36 feet. So, ngayon, you can now compute for the length ng RBF. No? Using this formula, so you compute for VUS, which is 13.56. Ito yan, no? 13.56. Okay, so inuna ko palang sinulog to. And then, yung prod number. So, we have this formula. We just need to substitute all the givens here. So, we have this prod number na 1.098. And then, we can now compute for the length nung hydraulic jump, no? So, we have 4.65 feet. Okay, so okay na tayo sa RBF. Ngayon, meron tayong GBF. So, we perform the GBF dito pa rin. Okay, so for the zoning, we have S1. So, we have the upstream and the downstream. So, downstream stripe is equivalent ng YN ng mild slope, which is 9.24 feet. So, yung YUS, so considering the upstream side of the GBF, so yung YUS, na-compute na natin yan sa RBF, di ba? So, that is 5.36. So, we have 75.04 square feet. And then, we compute for the perimeter, 24.72 feet. We compute for the hydraulic radius, 3.04. We compute for the velocity, 11.99 feet per second. We compute for the velocity head, which is 2.23. We compute for the specific energy, we have 7.59. And now, we can have the friction slope dito sa upstream side, which is 0.00213. Okay, and now, we can now consider the downstream side sa GBF natin. Okay? So, considering the downstream side ng GBF natin, so bali yung YDS natin dito is 9.24. So, the same process, we compute for the area sa downstream side. 129.36 square feet. Perimeter is 32.48 feet. Hydraulic radius is 3.98. Velocity is 6.957 feet per second. Velocity head is 0.75. Specific energy is 9.99 meters. And we can now have the friction slope dito sa downstream side, which is 0.0005. So, meron ka ng friction slope sa downstream and upstream. So, like, you can now compute for the average friction slope, which is 0.001315. And you can now compute for the length of reach nung GBF natin. No? So, using this formula, we just need to substitute kasi may mga values na tayo dito lahat. And we get 1424.3 feet. Okay? So, I think that's it, no? For RBF analysis. Sobrang haba. Okay, so sa next video, we will be discussing typical step in canal design. So that would be sa next na video. Thank you.